Welcome dear students to today's session of Summit for Max. Please subscribe the channel and press the bell icon for further notifications. Let's get started. In today's session, we are going to see about complex numbers. Try to answer the question whether there exists a real number whose square is negative. Let us look at simple examples to get the answer for it. Here we have an equation x squared minus 1 is equal to 0, which can be written as x squared is equal to 1. So, solution for x is plus or minus 1. The second equation we have here is x squared plus 1 is equal to 0. We can write it as x squared is equal to minus 1. What is x here? Any guesses? Here, equation 1 has two real solutions, but equation 2 has no real solutions. Then we must create an imaginary number as a square root of minus 1. This imaginary unit of minus 1 is denoted by I, which tells us I squared is equal to minus 1. Here we have some powers of imaginary unit I. Please make note of it. Here we have a question I to the power of 1947 plus I to the power of 1950, which can be written as multiple of 4. So I to the power of 1947 can be written as 1944 plus 3, and 1950 can be written as 1948 plus 2. The next step is write 1944 as a product of 4 and 486. So 486 to the power of 4. And I cube can be split as I square into I plus I to the power of 1948 is split into 487 to the power of 4 into I square. We know that I to the power of 4 is equal to 1. The next step reduces to 1 to the power of 486. Here the powers can be interchanged, that is I to the power of 4 whole to the power of 486, which is 1 to the power of 486. Hope you understand. And the next part is I to the power of 487 whole to the power of 4 can be interchanged and written as I to the power of 4 whole to the power of 487, which is equal to I to the 1 to the power of 487. And I squared is minus 1. I should be written as it is plus 1 to the power of 487 into I squared is minus 1 here. So we get minus I minus 1, which is minus of I plus 1. Try out this for homework. I to the power of 1948 plus minus I to the power of minus 1869. The next problem we have here for today's session is summation n is equal to 1 to n I to the power of n plus 50, which is I to the power of 1 plus 50 plus I to the power of 2 plus 50 plus etc. plus I to the power of 10 plus 50. which can be written as I to the power of 51 plus I to the power of 52 plus etc. I to the power of 16. Here I to the power of 50 can be taken as a common term from all the functions, and we have in the bracket I plus I squared plus I to the power of 3, I to the power of 4, I to the power of 5, I to the power of 6, I to the power of 7, I to the power of 8, I to the power of 9, and plus I to the power of 10. So here we are going to group the terms as the first 4 terms to a group and second 4 terms to a group and last 2 terms. So I plus I squared plus I cube plus I power 4 is actually I plus I square is minus 1, I cube is minus I plus I power 4 is plus 1. So we get 0. The next step is I to the power of 50 can be written as 48 plus 2. And the first set of brackets will become 0. And the next bracket will reduce to I to the power of 4 plus 1, 1 plus 4, I to the power of 2 plus 4, plus I to the power of 3 plus 4 plus I to the power of 4 plus 4, and I to the power of 9 can be written as 8 plus 1, and I to the power of 10 as 8 plus 2. The next step is I to the power of 2 into 0 plus I to the power of 1 plus I to the power of 2 plus I to the power of 3 plus I to the power of 4 plus I squared. I to the power of 9 and 10 will reduce. Here I squared is minus 1, 0 plus I squared, which is equal to minus 1 into I minus 1, which is equal to minus I plus 1. So 1 plus I is your answer. Hope you enjoyed today's session. Try this for homework. Summation n is equal to 1 to 12 I to the power of